Hi everyone, you're welcome to today's lesson in mathematics. And in this lesson, we'll be looking at binary. What is binary? Binary is a number system, and it's also known as a base 2 number system. It's a system of numbering where only 2 digits are used. Okay, it's a numbering system just like you have the decimal number system or the base 10 number system. Binary is also just like that, but in this case it has just 2 digits. Only 2 digits are used. Okay, and it's referred to as the base 2. It's also referred to as the base 2 number system. For us to properly understand the binary system is we're going to first take a look at our normal base 10 system, or which is also known as the decimal system. We'll take a look at it because a lot of the rules that apply in the binary number system also apply here. And since we are already familiar with the base 10 number system, we're going to start from here so that we're able to gain a good understanding of the binary number system and how it works. Okay, so remember I mentioned the binary system uses 2 digits only, and the digits are 1 and 0. 1 and 0 are the only 2 digits used in this binary system of numbering. So let's go to the base 10 system, refresh our minds on it and how it works, because sometimes we use things without even being mindful of the rules that apply. So in the base 10 number system, which is also the decimal system, you have 10 digits that are in use. I know in our earlier lessons I mentioned that all the numbers you find in existence, all the numbers you can think of in the Arabic numerals are formed from these 10 digits. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the digits from which all the numbers, no matter how large they are formed from these digits. 9 is the highest digit in these units. In these digits, 9 has the highest value, is the highest unit number. Okay, so in our normal base 10 system, you find that when you get to 9, which is the highest unit number, you can't go, there's no other number or symbol to continue to represent numbers after you get to 9. You know, it's like, okay, no other thing to represent the next number. You have to reset. What do I mean by reset? We have reached a level where we have run out of symbols. Now we want to go back to using the symbols that have been used before. But then we're going to use them differently now because they're going to carry different values. So remember, when we get to 9, the next number normally is 10, 1 and 0. Why is it 10? 10, we are resetting this unit side to 0 because there's no other unit, no symbol to represent it anymore. So this unit end, remember unit and tens, the unit end that carries all these numbers has reached the limits. It has reached the point of the highest number and it can't go further, no other symbol. Okay, so it has to reset to 0, which is the least the least digit amongst them. And then what happens? The extra spills over to the next position, the next column, which is the tens position. When you get to the highest number in that system, you have to reset and you go back to the least number, which is 0, and then the extra spills over to the other column as 1. So in this case, when you get to 9, after 9, if you add extra units, it becomes 10. No symbol to represent 10. So we go back to 0 coming under the units, and then the bulk of 10 converts to 1 under the tens column. The way this one works is exactly the way the binary system works. Remember, we said the binary system has just 2 numbers it uses, numbers 1 and 0, or 0 and 1 is the same thing. Okay, just like you have 0 to 9 in the binary system, you have just 0, and 1. Those are the only 2 digits that are used in this system. Okay, now I'm trying to take time to help you understand the transition of 9 to 10. Okay, because if you're able to understand that, you'll be able to get how numbers are formed in the binary number system. When you get to 9, you have reached the highest symbol that is used to represent values in number system. You have reached the highest number in this decimal system, and for you to continue, you have to reset. So in that resetting, the unit now goes back to the smallest value, which is 0 among them, and then the real value now translates as 1 to the next column, in this case, which is the tens column. So like we mentioned, in the number base 10 system, which we are used to, when you get to 9, like I mentioned, there has to be a reset. So this is 9 here, and remember, every number you see has a 0 behind it. It's not written because it doesn't have value, but that doesn't mean it's not there. It's there. Even this number 09 is the same as 009, is the same as 9, is the same as 0009. Okay, every number you see, or every digit, every number you see has a 0 at the back of it. So this 9, when you add an extra unit to it, an extra digit of 1 to it, there is no more symbol for, because we have reached the highest value of the digits that form numbers. No more extra symbol to represent it. So we are falling back to the beginning. So this end can't take extra weight. It goes to 0. Then that extra that it cannot take translates to the next column. Here you see 0 behind 9. So that 1 from this unit moves on to this other column, and 1 plus 0, it gives you 1. So you have 10. That's how you get your 10. Now you continue. To get 11, you are adding an extra unit again. Now here is 0. So 1 plus 0 is 1. This place can take extra unit. So you add 1, you get 11. This place can still take extra unit. You add 2, you get 12. This space can still take extra units. You add 3, you get 13. Until you get to 19. When you get to 19, again you have reached the highest symbol or digit that can be used in this unit section. So any extra addition you do again, this column cannot take it. This position cannot take it. So it gets reset again to 0. This 9 plus 1, it makes this thing to be reset again to 0. And that one that this column cannot take, remember, this place is still available. It can take it. So you move it to the next place, and it becomes 2 and 0, which is 20. So you continue adding. If you add 1 here again, this place can take addition. So it's become 2 and 1. If you add 2, it becomes 2 and 2, which is 22. If you add 3, it becomes 23. Just like that, until you get to 29. 29 again, we have reached the highest number that this column can take. Okay, we have reached the highest value, and so there has to be a reset again. Any extra addition of 1, this part cannot take it because there's no extra symbol to use in representing the number. So we go back to 0 for this part. Then that 1 that this place cannot handle goes to the next column, which is the column of tens. And the number becomes what? 3 and 0, which is 30. So that's how this transition occurs. Now let me quickly show you one before we go to binary. Okay, I don't want this part to look confusing. So let's just quickly go to the number 99. 9 and 9. Okay, so what happens when you get to a number like 99? Remember, 9 is the highest digit, okay, that we have, and that can be contained in every unit column. So if you add extra 1 now to this 9, it can't take it. This place has no extra symbol to represent it, so this position has to be reset to 0. I hope we can see that. Okay, let me write it here. So you have 99, okay, and then if you add extra 1 to this 9, it becomes 0, because we cannot represent it with a single other symbol. There is none. Okay, so plus 1 here makes this portion to be reset to 0. And then that extra one that made this to be reset comes to the next column. But again, the next column has 9, which is the highest digit. That means this column too has to be reset. It can't take it. And then lastly, that extra one, you move it to a third column. Okay, you remember your unit tens and hundreds? Yeah, it moves it to the tens column because there's always space for a number to keep increasing towards your left. That is how you form the number 100. 9 can't take it. Take an extra unit. It becomes 0. It's reset. You add it to the next 9. It can't take it either. And then you take it here. You have your 100. Okay, so I'm just taking time to go over this because if we are able to understand it, then we'll be able to understand how the base 10 number system works. Okay, so we'll be looking at numbers 1 to 10. Okay, for this lesson, though we consider some other numbers, but we focus on how we build the binary system, number system from 0 to 10. We're going to look at that. Okay, so we're going to take a look at the numbers from 0 to 10 in the binary system and see how they build. So 0 in our own base 10 number system is the same as 0 in the binary system. 1 is the same as 1, but that's how far we get. Okay, the other numbers now have to be repeated using just these 2 digits in the binary system. You know, like in the base 10 system, we have numbers from 0 to 9, but here we have only 0 and 1, only two digits. That's why it's a binary system of numbering. Binary means 2. So we have 0 as 0 and we have 1 as 1. So what is 2? Since there is no 2 in the binary number system, how do we write 2? Now let's see how 2 is formed. Remember, 2 is 1 plus 1, right? And both are single digit numbers. So 1, sorry, let me write it more clearly. 1 plus 1. Let me do it this way. It's supposed to give us 2, right? But we don't have 2 there. So we reset it to 0. Exactly the way we would do if we are adding 1 to 9. You know, we can't write any symbol. We don't know any other symbol. So 9 plus 1 will give you a reset in that unit, which is 0. And then the 1 is moved to the next column. That's exactly what is going on here. Because we don't have 2. The highest number we have in the binary system is 1. So after this 1, if you are adding any extra unit of 1 to it, we reset it to 0. And then we move that 1 to the next column, which gives us 1 and 0. Okay? 1 and 0. This is what 2 is in the binary system. 1 and 0. Because 2 is simply 1 plus 1. So if you add 1 plus 1 ordinarily, it gives you 2, but we don't have space for 2 in binary system. So you reset it to 0 and move the 1 to the other column. I hope that is clear. So let's move to the number 3. Let's see how 3 is formed. What is 3 ordinarily? 3 means 2 plus 1, isn't it? It's 2 plus 1. And now let's come to our binary number. What is 2? 2 is 1 and 0. So that means you are doing 1 and 0 plus 1. Okay? So 1 and 0, if you look at this space now, 0 plus 1 is 1. We have 1 in the binary system, so we write our 1. And 1 plus nothing is 1. So 2 plus 1 here is 1, 1. 2, which is 1 and 0 plus 1 is 1, 1. So 3 is 1, 1. We don't call it 11 because that's not what it is. Neither do we call this one 10 because it's not 10. It's 1 and 0. So this is 1 and 1. That is the number 3. So let's see how we form number 4. Number 4 is simply 3 plus 1. Right? So what is our 3 here? Our 3 is 1, 1 in the binary system plus 1. Now, if you do 1 plus 1, again, you find that we don't have 2 in the binary system. It's supposed to give us 2. But is there 2 in the binary system? No. There's no symbol like that in the binary system. So what do? We reset this to 0. You reset to 0 and you bring the extra 1 to the next column. Now bringing the extra 1 to the next column, it gives you 1 plus 1 again, because you have to add that extra 1 to the one that is already there. So 1 plus 1 again is going to give us 2, and we don't have 2. So again, you reset to 0, and then you transfer that 1 to the third column, which gives you this one here, 1 0 0. So the number 4 in the binary system is 1 0 0. Let me go over that again. Remember, 4 in our normal base 10 value or base 10 number system is 3 plus 1, right? And we have gotten at 3 here. So to get 4, we are adding 1 to 3. 3 is 1 1. And to get 4, we are adding 1 to this 3. 1 plus 1 will give us 2, but we don't have 2 in the binary system, so we reset it to 0 and carry 1. That 1 again plus the 1 that is already here is another 2. We don't have 2, so we write 0 again and carry 1. So that one we carry, we bring it to the third column, which is the one we have here. So the number 4 is 1 0 0. Are we following this? Okay, so let's see number 5. Normally 5 will be 4 plus 1. Please pay attention. I remember way back in secondary school when I was taught binary, I never understood it, really. I never understood it, and I didn't bother after at least I was able to pass my exams. I didn't bother about it, but after some time I was able to understand the whole system, how it works and all of that. So please pay attention. It's a tricky thing, it's a tricky one, but once you understand how it is, you enjoy it. It's an interesting maths concept. Okay, so 5 is simply 4 plus 1, and here we have gotten 4, and 4 is what? 1 0 0. Okay, so we are adding 1 to this 4, so we bring it under. Remember, we always have the right end where we start our arrangement. So when you add 1, 0 plus 1 is 1, 0 plus nothing is 0, and 1 plus, that is 1 0 1. So the number 5 is 1 0 1. Okay, so 5 is 1 0 1. Now let's see our number 6. Remember, number 6 is what? 6 is what? 5 plus 1. 5 plus 1 gives you 6. So our 5 is what? 1 0 1. 5 is 1 0 1 in binary number. So add 1 to it to make it 6. So 1 plus 1 is going to give us 2, but we know there is no 2 in the binary system. So again, we reset to 0 and we bring the 1 here. So the 1 plus 0. Okay? 1 plus 0 is 1, and then 1 plus nothing is . So the number 6 in the binary form is 1 1 0. Okay, let's go over it again. The binary number 1 0 1 is 5, okay, and 6 normally is 5 plus 1. So these are 5, which is 1 0 1. We are adding 1 to it. Now 1 plus 1 will give us 2, but we know that there's no 2, so we reset to 0 and bring the extra 1 here to the middle. It gives us 1 plus 0 1, and then the last one 1 plus 0 1. So 6 is 1 1 0. Okay, so the next digit we're looking at is 7. Again, 7 is same as 6 plus 1. 6 plus 1 is 7, and we have seen our 6. 6 is 1 1 0. So we're adding 1 to 6. We're adding 1 to 6. Please remember, your addition is always at that right end, the extreme right end, which is, you liken it to the unit end. Please, that's the end you always add to get the next number. So 0 plus 1 will give us 1. 1 plus nothing is 1, and 1 plus nothing. So the number 7 is 1 1 1. Just add 1 to 6 at the unit end and you get that. 7 is 1 1 1. So the next number we look at now is the number 8. And 8 ordinarily is 7 plus 1. Okay? So what is 7? 7 is 1 1 1. So plus 1 We're looking for 8, remember? So we add 1. Okay, so here we go again. 1 plus 1 is 2 normally, but we don't have 2 in the binary system, so there is a reset to 0. We carry 1. 1 plus 2 is, 1 plus 1 is 2 again. We are resetting to 0 because there is no 2 in the binary number system. And the 1, we carry it forward again. So 1 plus 1 again, we don't have 2. We write down 0. Since there's no number else to transfer that 1, we now write it here. Let me just quickly show you something. This is like saying 999, plus 1. Okay, remember 1 is the highest digit in binary system and 9 is the highest digit in the base 10 system. Okay, so here when you have 9 plus 1 is 10, you write 0, carry 1. Then 1 plus 9 again is 10, you can't write 10, you write 0, you carry 1. And then you carry that 1 and bring it here. This 9 plus 1 again is 10. So now because there's no number to transfer that 1 to, you finally write it down. So we find out that this 1, 1, 1, which is 6 plus 1, will give us 1, 0, 0, 0. 1 plus 1, you write 0, move the 1 here. 1 plus 1, you write 0 because we can't write 2. 1 plus 1, we write 0 again, and the last one, we bring it here. Just like the way, if you're in the base 10 number system, when you're adding maybe 999, you're adding 1 to it. Exactly the way it turns out is how this turns out. Okay, I hope this is getting clearer. So the number 8 in the binary system is 1000. Again, I say you don't call this number like 1000 because it is not 1000. This is a different system of numbering. Okay, we call it 1000. Okay, so the next one we're looking at is the number 9. 9 is the same as 8 plus 1. 9 is 8 plus 1. Okay, so we have that this 8 is 1, 1, 2, 3, 1 and 3 zeros. So plus 1, you have this 1, 0, 0, 1, right? So you just add 1 plus 0, 1, 0 plus nothing, 0, 0 and 1. So your 9 is 1, 0, 0, 1. So the last number we're going to look at here is the number 10. 10 is the same as 9 plus 1. And we have seen that 9 is what? 1, 0, 0, 1. So let's add our 1 to 9. 1 plus 1 is 2. We don't have 2 in the binary system, so we reset to 0 and bring the 1 here. 1 plus 0 is what? 1. 0 plus 0, 0. 1 plus nothing, 1. So we have 1, 0, 1, 0. So the number 10 in the binary system is 1, 0, 1, 0. Wow. Interesting, isn't it? It's interesting and it's simple. Once you just, I had to go over the numbering system, the base 10 number system, the way we transition when we get to the highest value, which is 9, okay? I had to go through that so that we understand. It's basically the same thing. Okay, just remember that in the binary system you have just 2 digits. 0 is the smallest, and well, I don't know if I would say smallest is the smaller number, and 1 is the bigger digit. So you have just these 2 digits. 0 is the smaller one, and 1 is the highest. 1 is like 9. Okay, you liken 1 to 9 in the base 10 number system. So whenever you are adding extra 1 to that 1, you know that there has to be a change. There has to be a transitioning. So if you are adding 1 to 1, for instance, I remember I told you that 0 is 0 and 1 is 1, okay? But when you get to 2, 2 means 0 plus 1. Now, how do we get 1? 0, to get 1, we are adding 1 unit to 0 and it gave us 1, okay? I think I didn't mention that clearly to us. You have 0 to get 1, it simply means 0 plus 1, it gives us 1. Now, to get 2, it's 1 plus 1. Now, if you add 1 plus 1 normally in the base 10 system, it gives you 2. But because we do not have 2 as a digit in the binary system, you have to reset it to 0. You write 0 and carry 1. It converts to 1, just the way it happens when you add 1 to 9, for instance. You will have to write 0 and carry 1 to the side of the tens, the position of tens. It's exactly the same way. So you write 0 and carry 1. So that one shows here, which brings the number 2 to 1, 0 in the binary system. Then when you want to go to 3, just add 1 to this 1 and 0. Remember, the 1 will stay under the 0, right? Like that. This is 10 and this is 1. Sorry, not 10, 1 and 0, and this is 1. Add 1 plus 0 is 1, 1 plus 1 is 1. So that's why 3 is 1, 1. 3 is 1, 1. And then we say for 4, 4 is what? 3 plus 1. So you write your 3 and you add 1. 1 plus 1 is 2. It can't hold. There is no 2 here in the system. So you reset to 0. Bring the 1 here. 1 plus 1 is another 2. No 2. Reset to 0 and bring the 1 to the third column. And you have 1, 0, 0 for 4. So that's how you build up to the number 10. Now, if you look at what we have here, the numbers, all the odd numbers, they end in 1. Like number 1, it's just 1. Number 3 ends in 1. Number 5 ends in 1. Number 7 ends in 1. Number 9 ends in 1. While all the even numbers, they end in zeros. All the even numbers end in 0. Okay, so that's how you convert from the base 10 number system to the binary system. That's how you convert from base 10 to binary. I hope it's clear. So next we're going to look at how we convert binary numbers to decimal numbers. And by decimal numbers, we mean the numbers in the base 10 system, the numbers we are used to, okay, like 10, 20, 15, 14, 25, those numbers, okay, they are the binary numbers. So we're going to look at how we convert these binary numbers, the numbers in the base 2 system, to the base 10 system. Okay, so the first step is whatever number, the decimal number you want to convert to the binary number, you will have to divide it by 2. You have to keep dividing it by 2 and you'll be writing down the remainder. You'll be dividing it and be writing the remainder. Mind you, in our normal base 10 system, when we are doing division, when you divide, you write down your main answer and you carry your remainder over and then you continue working until you get to the end. But in this case, it's the remainder you will be writing down. And again, in our base 10 number system, when you are writing answers, you write from your left and move towards your right. You graduate from your left and move towards the right. But in the case of this base 2 system of numbering or the binary system, as you are getting the remainder and writing them down, you are writing from right and moving towards your left. You are writing like, we will call it, you are writing backwards. Okay? So you start writing from your right and every answer you get, every next answer you get, you put it behind the first one. You keep working like that towards your left, okay? So you arrange your answers from right to left. And then the third step is you stop at dividing. You stop at dividing 1 by 2 or when there is nothing left to divide. What do we mean by that? If you are dividing an odd number, remember, by 2, you always get to a point where there is a remainder. There must be a remainder of 1. 1 must remain if it's an odd number that you keep repeatedly divide by 2. So when you get to that point, that will be the last step you will take, okay, in the division. Or if it's an even number, you will get to a point you totally divide everything and there will be nothing left to divide. So that's the point you stop. Okay, so this step is telling you that if it's an odd number, you stop when you finally get to 1 divided by 2. So you get your answer there and that's the end of it. Or if it's an even number, when you have divided everything and 0 is now left, then that is the point to stop. So you take note of your number which you have written out. All right, so let's take an example. Convert 5 to a binary number. Convert 5, remember this is in the decimal form, it's in the base 10 number form, so we are changing it to the binary form. Okay, so how do we go about this? You simply divide, you repeatedly divide this number until you get nothing else to divide by 2. So you start with 5 divided by 2. Okay, so you start 5 divided by 2. Now when you divide 5 by 2, you have 2 can divide 5 2 times and there's a remainder of 1. Right? We have 2, remainder 1. Now what did we say? Is the remainder you'll be writing down as your answer. Okay, while you continue to work with the main answer you got. So in this case, we have a remainder of 1, so we write our 1. And remember, the second rule says you arrange the answers you're getting, these remainders you are getting, arrange them from the right and work towards the left. So we write down the 1. Now you have 2 to work with. So the next step, let me just write here step 1, 5 divided by 2. Step 2 now is 2 divided by 2. Okay, 2 divided by 2. So that gives us, if you divide 2 by 2, what does it give you? It gives you 1, remainder 0. Isn't it? So if you divide 2 by 2, it gives you 1, remainder 0. So that means 0, which is the remainder, you will write it down to the left of that number that you have, the digit you have put down before. So you write, remember we're working from right to left, so 0 comes in this position. Now you have a number left, one more number, so we just say step 3 is 1 divided by 2. Remember you're constantly dividing by 2. Okay, so 1 divided by 2 is, 2 can't divide 1, so we say it is 0, remainder 1. So that gives us 1. And if you go to our numbers previously, you know, we did how to build from 1 to 10, how to build numbers in the binary system from 1 to 10. And you saw how we got our 5, you know, by simply, in fact, from 1, you saw how we got 2. When you added 1 to 1, it gave us 2, which we couldn't write, so we wrote 0 and 1. And then we added 1 to that, it gave us 3, 1 and 1. We added 1 to that, it gave us 0, 0, 1, which that is 4, 1, 0, 0. And then when we added 1 to 1, 0, 0, it gave us 1, 0, 1 as 5. And if you look at here again, using this method of conversion, 5 is also giving us 1, 0, 1. Okay, so this is a method for conversion when you're converting. Now, why we use this is you can have bigger numbers than 10, you know, to convert to binary numbers. So just use this system and you definitely get your answer. So we're going to take another example. So another example is 7. We're converting it to a binary number. Remember, when we built the first one, we looked at that we were building by adding 1 unit, we continue to add 1 unit till we got to 10. Remember, 7 gave us 1, 1, 1. Now we're going to see again how we can get this 1, 1, 1 using this method of conversion. So 7 divided by 2, it gives you 3 with a remainder of what? 1. So that one, remember, you put it down here. Please don't get confused with this. I just put it there so that we see how we're getting these numbers back. So the remainder is what you put down there. Now you continue working with the main answer. So the step 2, I'll just call it step 2. You do your 3 divided by 2. Remember, 2 is the constant number you are dividing with. So 3 divided by 2 will give you 1. 2 can divide 3 only once, and there is also a remainder of 1. Mark that remainder, bring it here, write it to the left of the number you already wrote. You are writing backwards. And then you have 1 left here. So as step 3, I'll just call it that, is 1 divided by 2. And 1 divided by 2, 2 is bigger than 1, so we just say it is 0, remainder 1. So this, the remainder, which is the 1, is what you're going to pull down here. So you find out that's a 7, which is 1, 1, 1, and we got from building serially. We also get it by using this method of conversion. Okay, maybe we should just take one more example before we move on to the other aspect. So the last example we are going to look at in converting decimal numbers to binary is 10. We're going to try and convert 10 to a binary number. Okay, so as usual, our first step is to divide 10 by 2. If we divide 10 by 2, we have 5, remainder 0. There's no remainder. 10 is an even number, 2 is also an even number. So when 2 divides any even number, there is usually no remainder. So we write down our 0. Right? So step 2, this is the 0 we have written down. Now we continue to work with the main answer here, which is 5. So we go to step 2, which is 5 divided by 2. And that gives us, if you divide 5 by 2, it gives you 2, remainder 1. So the 1, which is the remainder here, goes behind the 0. Write it to the left of that digit 0. And you continue working with the main answer, which is 2. So at step 3 here, step 3 gives us 2 divided by 2. And we know that when 2 divides 2 is 1 and there is no remainder. Remember, when 2 divides an even number, there's usually no remainder. 2 is an even number and it's dividing itself. So this is what we have. So this 0, again, you write it to the left of the existing digits. Okay, write it to the left of the existing digits. And step 4, we have step 4 because there is still a number left that we are working with. And that number is the digit 1. So you have 1 divided by 2, and we know 2 is bigger than 1, so usually we say it is 0, remainder 1. So that one comes right here. So 10 in 10 in the binary system or in the binary number is 1010. That is 10. Okay, so let's quickly go over it. Just continue to divide whatever number you're converting to the binary number with 2. Just keep dividing it by 2. Okay, so when you divide, the thing is, instead of writing your main answer down, you're going to be writing down your remainders, because the remainders will always be in 0 or 1. And those are the numbers we have in the binary system. So you keep writing down the remainders, keep writing down the remainders. So here you have 0, which is the first digit we wrote here. The next turn we divided, we had a remainder of 1, which came next. We now divided further, we had a remainder of 0, it came here. And lastly, we had the remainder of 1, and that is it. So when you are changing from base 10 number to a binary number, you just keep dividing by 2 and then noting down the remainders. But the thing is, you have to write them from right to left, like you're writing backwards. That's how you represent those remainders until you get to the last part, which in most cases is 1 divided by 2. So you always write 0, remainder 1. Okay, could be that, it could be something else, but basically that is how we do our conversion from the base 10 number to binary numbers. So the next aspect we're going to look at is converting binary numbers to decimal or base 10 numbers. Remember, we just looked at converting decimal or base 10 numbers to binary. Now we're going to see how we convert binary numbers to decimal or base 10 numbers. Okay, so let's take this example. Convert, what number can we use? Let's take this number in the binary form, this number 111. Let's try and convert it to our base 10 number. Okay, now how does this work? Okay, maybe I should give you the rules. I think it will help. So let's quickly look at how it goes when we need to convert from binary number system to the decimal or base 10 number system. Okay, so I just wrote this out for us to like get a glimpse of how it works, but I know that when we start working with examples, we get a clearer picture. So to do this, what you do, let me put this, what you do basically is you pick out each digit in the binary number, every single digit in the binary number. You're going to be multiplying each of them. You multiply each number in the binary, each digit in the binary number, you multiply with the powers of 2, okay? And you start from 0. You start from 0 to multiply each of the digits. Okay, there's something else we need to take note of. We multiply these digits from the right end. Remember, the right end is the smallest end that has the smallest value. So we multiply these digits from the right end and we work towards the left, to the left. So we work from the right to the left. You're going to pick each of the binary digits, the digits that form the binary number. You're going to pick each of them and multiply them with powers of 2, starting from 0. That means 2 raised to power 0, 2 raised to power 1, 2 raised to power 2. So you use them to multiply each of the digits, and you start from your right and you work towards your left. Then at the end of the day, you add up. After multiplying, you add up everything to get your number in the base 10 system or in the base 10 form. Okay? To do this, we multiply every single digit in the binary number with the powers of 2, like you say 2 to the power of 0, that's the power of 2, or 2 to the power of 1, or you say 2 to the... So you keep using something like this to multiply each of the digits in that binary number. And then you are doing that starting from your right and working towards the left. You pick one digit, multiply, pick the next, just like that. And the powers keep increasing by 1 until you get to the last one. When you have finished, you carry out the multiplication, get the answers, add everything together. And the answer you get will be your number in the base 10 form or in the decimal form. So let's take an example. Okay, to help us to understand better. So we are going to, this is a number in the base 2 form. Okay, please look at this. There's something I wrote here. I wrote a little like a subscript at the bottom, the right end of this last digit in this number. You can see the 2 there. Okay, it's a subscript. That shows that this number 100 is not 1000, it's not 1000, but it's a number in the base 2 form. So this is how you represent it with this small 2 at the... Anytime you see a number and there is this 2 written at the bottom of it, just know that that number is not in the base 10 form. It's not the normal number we use, but it's in the base 2 form. It's a binary number. So let's see how we change this to a number in the base 10 system. So like I explained earlier, I say you start working from the right towards the left, like you are working backwards. Okay, it's like you are working backwards. Now if you look at this, the last digit here is 0, so you will pick that 0 first. Remember, we said we are multiplying every digit in this number with the power of 2. We multiply every digit in this number with the power of 2. Each of these digits will be multiplied by the power of 2. So the first digit we are picking is from the right end here, 0. That's the 0 you have here. So 0 times 2 raised to power 0. And by doing the power of 2, you multiply the power of 2, we are starting with the smallest value of the power of 2, which is 2 raised to power 0. You always start with that. So the first digit here is 0 times 2 raised to power 0. Bracket, put it in bracket, plus, because you're going to add every single value together, plus the next number you see there is another 0. So this is the second 0. So 0 times 2 raised to the power of 1. You know, after 0 you have 1. Remember, the first 2 here is to the power of 0. The next 2 is to the power of 1. the next 2 will be to the power of 2, and the next will be to the power of 3. That's how it keeps increasing, by 1. The powers of 2 keeps increasing by 1. So the next number, which is 0, is 0 times 2 to the power of 1, plus the third digit is also a 0. So the third 0 is times 2 to the power of 2. From 0 to 1 to 2. You're seeing it? How the power is increasing. So this is to the power of 2. Then plus, the last digit we have here is 1. And that is 1 times 2 to the power of 3. Okay? Remember, the first one is to the power of 0. Second one to the power of 1. The third one to the power of 2. And the fourth one is to the power of 3. Now we're going to add all this together. By the time we add them, first we carry out our multiplication and then add all the answers together to get our final answer. Okay, so let's start with this first one. 0 times 2 raised to power 0. First, what is 2 raised to power 0? 2 raised to power 0 is the same as 1. Any number at all raised to the power of 0 is 1. Even if it is 1 million. You raise 1 million to the power of 0, it gives you 1. 60 raised to the power of 0 is 1. Any number raised to the power of 0 is 1. So 0 times 1, that gives us 1. Any number, that gives us 0. Any number multiplied by 0 is 0. So this whole thing in the first bracket here gives us 0. And then we move on, add. That's the addition sign there. So 0 times 2 raised to power 1. So what is 2 raised to power 1? 2 raised to the power of 1 is 2. Okay? But 2 times 0 will bring us again to 0. Okay, let me write this here, that 2 to the power of 0, this 2 to the power of 0 is equal to 1. Right? And 2 to the power of 1 is 2, but 2 times 0 gives us 0. So we have a second 0 now. Plus, we are moving to the third value. 2 to the power of 2 means 2 times 2. And 2 times 2 is what? 4. But then, we are still multiplying 4 by 0. Remember, any number multiplied by 0 is 0. So this whole bracket, again, the value here amounts to 0. Right? Then plus the last one, we come to the last bracket. And that is 1 times 2 raised to the power of 3. So first, again, we solve the power, the one that is in the power here. We have to solve that first before we do the rest. So 2 to the power of 3 means 2 times 2 times 2. That's what 2 to the power of 3 means. 2 times 2 times 2. And 2 times 2 is 4. 4 times 2 is what? 8. So that means in this bracket, what you have is 1 times 8. 1 times 8 is what? Is 8. So what do we have? We are going to add everything here together to get our final answer. 0 plus 0 is 0. Plus 0 is 0. Plus 8 is 8. So this number that we have up here, this 1000 in base 2 is the same as the number 8. Let's run through it again, and then we take another example. So this is a number in the base 2 form. We want to change it to the decimal form or the base 10 form. So we said that when you are doing this, each digit in the binary number must be multiplied by a power of 2. And in doing that, you start from the digit that is at the extreme right end and you walk backwards towards the left. So you pick the number at the extreme right end, you start from there, multiply it by power of 2, but the least power of 2, which is 0, and then the next one you multiply it by the power of 2, that is 1, the next one by 2, and the powers keep increasing by 1 step as you move towards the left. So here in this example, the last digit that we have here to the right is 0. So we say 0 times 2 raised to power 0. Remember, we are not saying 2 raised to power 0 because the number is 0. Even if the number is 1, as long as it's the last number we have on this right hand side, the power of the 2 must be 0, because that's where we start with. That's where we start. So this 0 is 0 times 2 raised to power 0. in bracket, then plus, you come to the second 0. 0 times 2 raised to power 1, okay, plus, you come to the third 0. 0 times 2 raised to power 2, plus, the last digit here is 1. 1 times 2 raised to the power of 3. So if you look at it, each of the numbers here, from right to left, 0, 0, 0, 1, 0, 0, 0, 1, they are written now. And then if you look at the power of 2, multiplying them, here you have 2 to power 0, 2 to power 1, 2 to power 2, and 2 to power 3. That's how it continues. If there were more digits here to the left of this one, the next one would be that digit times 2 to power 4. The next digit times 2 to power 5. That's how the power keeps increasing. Okay? So at the end of the day, we multiplied all this together. 0 times any number is 0. So that's why you have 0, 0, 0 here. Because whatever these numbers amount to, once you multiply them by 0, they become 0. So we have 0, 0, 0. And then the last bracket has 1 times 2 to the power of 3. And 2 raised to the power of 3 means 2 times 2 times 2. That's 2 in 3 places, multiplying itself. 2 times 2 times 2. And 2 times 2 is 4. 4 times 2 is 8. So that gives us 0 plus 0 plus 0 plus 8, which leads us to 8 as the answer. That means the number 1000 in the binary form, in the base 2 form, is equal to 8 in the base 10 form. I hope we are following. So let's take the next example. So here we're converting 1010 in the base 2 form to a decimal number. Converting 1010 to a decimal or a number in the base 10. Remember, when they say decimal number, it also refers to numbers in the base 10 system or base 10 form. Okay, so here we have 1010, and using our general method of converting this, we start with the number at the extreme right. Okay, remember we work from the right towards the left. So we start with the number at the extreme right, which is 0, and it gives us 0 times the multiple, the least multiple of 2 that we're starting with is 2 to the power of 0. So you have 0 times 2 raised to power 0, that number is gone. And we move to the next number to the left, which is 1. So it gives us 1 times 2 to the power of 1. Because after 2 to the power of 0, you have 2 to the power of 1. And then the next number is 0. 0 times 2 to the power of 2. And the last number here is 1. 1 times 2 to the power of 3. Please just know that the power of 2, it starts from 0 and it just keeps increasing by 1 unit. It's not difficult to remember. It starts from 2 to the power of 0, it moves to 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. If there were other numbers, 2 to the power of 4, 2 to the power of 5, just like that. Okay? So once you know that, all you just need to know is, okay, I'm starting from my right, I'm moving towards the left, and I'm doing this same thing to every single digit. This thing I'm doing is going to be done for every single digit. So you start with the number at the extreme right and you move backwards. 0 times 2 to the power of 0, 1 times 2 to the power of 1, 0 times 2 to the power of 2, and 1 times 2 to the power of 3. So now we have done this, the next step is to add all of them together. So the next step is to add. Well, before you add them, actually you find out the values of this stuff. So we first do that before adding. Sorry. So for the first bracket, you have 0, and we said that 0 times anything is 0. Okay. Actually, 2 raised to power 0 is 1. So it's 0 times 1 that we have here, and that gives us 0. Okay, this first bracket gives us 0, and then we move on to the second bracket, plus, remember your plus, 1 times 2 raised to power 1. So 2 raised to power 1 is the same as 2. So 1 times 2 is what? Is 2. We move to the plus here, put your plus sign. So the third bracket has a 0 multiplying a number. So though 2 raised to power 2 is 2 times 2, which is 4, but at the end it is 0 times 4, and it comes to 0 plus this one. The final number we have here is 1 times 2 to the power of 3. 1 times 2 to the power of 3. So that means 2 to the power of 3 is 2 times 2, 4, and 4 times 2 is 8. 2 to the power of 3 is 2 times 2 times 2, which is what? 8. So 1 times 8 is 8. The value of everything inside this bracket is 8. Now we have done this. The last step is to add them together. Okay? Add them together. And what do you have? 0 plus 2 is 2. 2 plus 0 is 2. And 2 plus 8 is 10. So we find out that this number 1010 in the binary form is equal to 10. Is equal to 10. So 1010. Okay? So this is basically how you do your conversion. This is how you convert. Just take note of the binary number that you want to change. Just once you have the steps in mind, like this is how I should go about this, you will just find out that it's so easy, right? So you know that each digit in this binary number, you're going to multiply them with the power of 2. And at the end of the day, whatever values you get, you add them together. And remember, you start from the right and work towards the left. Those are just the basic steps to remember. And one, you're going to pick each digit and work with them. Use the power of 2 to multiply each of them. Then also have it in mind that in doing this, I'm starting from the right, the very last digit to the right, and I'm working backwards. And then note that in using your powers of 2 to multiply, the powers of 2 starts from 0 and it keeps increasing by 1 unit until you get to the last number or the last digit. Okay, and at the end of the day, whatever you get, you add them together and you get your final answer. Okay, so here we have the last digit to the right is 0. We started with 0. 0 times 2 raised to the power of 0. 1 times 2 raised to the power of 1. 0 times 2 raised to the power of 2. And 1, the last one, times 2 raised to the power of 3. So you see the power of 2 started from 0. It moved to 1 here. It moved to 2 here. And moved to 3. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. And at the end of the day, you carry out your multiplication within the brackets and then add the values you get together. You will get your answer. So in this case, 1010 is equal to 8 in the base 10 form. And if you go back to the numbers we built at the beginning of the lesson, where we were just trying to add 1 unit to the numbers, you will find out that your 10 is actually 10. Okay, 1010 is 10. So you find out that in that number that we built at the beginning of the lesson, your number 1010 is the same as 10 in the base 10 number system. Okay, here is where we're going to call it a day. There is a lot to learn in the binary system, but I don't want to overload you with information. If time permits, we're going to do a video on how to add binary numbers, how to subtract binary numbers, how to multiply binary numbers. We will try and make a video on that. But for now, we're calling it a day. And please help us like and share this video. And if you haven't subscribed to this channel, we beg you to do so. Okay? Hope to see you next week. Stay blessed and stay safe.